6, we're going to pick up from the idea of systems of equations, but now we're going to apply them so we can see in word problems how they relate. Example here. In the first example, it says Jim has $17 more than Sam. They have $73 together. How much money does each of them have? Now, you could use trial and error, obviously, and try numbers all day long, and you could probably get to the answer. But let's take an algebraic approach, as we always talk about, since we're in algebra class. So what would the algebraic approach be to this problem? What's the first step there, Charles?
Let S equal the amount of money that Sam has.
Okay, the money that Sam has. Great. And then the other one?
So S plus 17 equals 73.
S plus 17 equals 73 is what you're saying?
S plus S. So 2S plus 17 equals 73.
Can we use two different variables? Is that all right, since we're doing two variables?
Oh, you want me to use two different?
Yeah, let's use two variables.
S plus J. Oh, we got to do a let's take root for J then.
Gotcha. All right. And then keep going.
S plus J equals 73.
Okay, what Charles was doing in the beginning was he was trying to avoid having these two variables, which works. You can do it that way. But just because we're looking at systems now, I'm going to stick with two variables just to produce the answer in the same way. But you can definitely use one variable in this problem if you knew what you were doing. What would the second equation be? What would the second equation be?
S plus 7, no, J plus 17 equals S.
J equals what?
J plus 17 equals S.
And that tells me that Jim plus 17 is what Sam has. Read the first line. Read up here. Jim has 17 more than Sam. You wrote it as Sam has 17 more than Jim.
S plus 17 equals J.
Okay, does everybody see what I'm pointing at there? If I were to read this aloud, I would read this as Sam has $17 more than Jim. But up here it says Jim has 17 more than Sam. So these two variables are just switched. Okay, so let's switch them back real quick. This should be an S here, and this should be a J over here. Okay, again, that's how I would read this. Jim has 17 plus, as in more than, Sam. And then as Charles told us, they have 73 together, so Sam plus Jim is $73. Now, what method of solution would you naturally choose here? Because it's easier, because it makes more sense.
Substitution,
Why?
because you already have an equation that equals J, so you
Yeah.
can just substitute J into the first equation.
Okay, exactly. Good, Sabine. So we just take that and sub it in. And that's where Charles came up with that equation he said in the beginning. Charles started us off with S plus 17 equals 73. And that's what we get as a result. If we take this quantity, S plus 17, and plug it in for J, we get exactly what Charles was alluding to in the beginning, okay, or saying in the beginning. So we get 2S plus 17 equals 73. Subtract 17 from both sides. We get 63 plus another 7 is going to be 56 equals 2S. And then divide by 2. So S equals 28. 28 has units of what? What are the units on 28? Because these are word problems now. Dollars. Good, Paul. Because we started the problem and said how much money do they have. So we're looking for the amount of money they have in dollars. Okay, in dollars. If Sam's money is $28, how can I easily get the amount of money that Jim has? Niall.
17.
Subtract
Subtract 17.
17?
17.
Add 17. So Niall is saying, let's take it and plug it back in up here. And we know that Jim has 17 more than Sam. So add 17, giving us 45. So if I were to write a verbal statement, tell me what you would write. I'm not going to write it, verbalize what it would be, Mike. Yeah, just a sentence at the end. How would you say it?
Sam has $56, while Jim has $45.
28, right? Not 56. Yeah. Divide by 2, don't forget. So good. Sam has $28 while Jim has $45. All right, please make sure you make some sort of a verbal statement at the end. because S equals 28 and J equals 45, although being solutions to equations, are not really a solution to a word problem. Okay, we always want to make some sort of a statement so we know what we're referring to. Does that make sense so far? I think that's a relatively easy kind of problem for word problems. It's pretty straightforward. You're given two sentences. Each sentence gives you a different equation, and you're taking those equations and you're solving them simultaneously. The second problem is a little bit more tricky than the first one. Thanks for that. Go ahead, Ryan. Read for us.
Consider that it took 3 hours to fly 1,100 miles in the direction of the jet stream. The return trip against the jet stream took 4 hours. What was the jet speed in the air, in the still air, and the wind speed in the jet stream?
So we want two things. We want to know how fast is the jet itself actually traveling, assuming there was no wind, right? And then what is the wind speed? What is a jet stream? What is a jet stream? You learn about this at some point in science. The direction of the wind current, yeah, or some sort of fluid current. So there's jet streams in the air. There's also jet streams in the water. It's a convective current of fluid or of water, H2O, whatever's in the ocean, and salt, that moves along a certain path. So the jet stream also exists in the atmosphere. So sometimes flights will take longer than others. And you've noticed that probably if you've flown before, that specifically if you're traveling with the jet stream, it will take you less time. The jet stream helps you. It pushes the plane in a sense. But if a plane is traveling against the jet stream, it may take longer. So that's the premise of this problem. All right, it says it took 3 hours when it's in the direction of the jet stream, and then against the jet stream, it took 4 hours. What's the equation that we've learned already this year that relates some sort of a speed or a distance traveled or any of that information?
Distance equals 3 times 10.
Yeah, D equals RT. So let's start with that. D equals RT. Now, the distance traveled in both scenarios, on the way there and on the way back, is 1800. It doesn't change. So I know I've got two equations right now. One on the way there. Oops, 1800, not 18. One on the way there, we'll call that R1. And one on the way back. But I don't have enough information yet. I need to do more because I can clearly see that there's a slight problem here. Well, it looks like right now, I don't have enough information to see what the actual answer is. So what else could I do? What else could I do? I have to do something else. Tina? T1 and T2, right? Yeah, that's right. So 3 and 4, right? Because they're times. So we've got 1800 equals R1 times 3, 1800 equals R2 times 4. But here's the problem right now. What are R1 and R2? What are they physically?
Speed
The speed when?
that it took to travel.
The speed of what? Like, there's more than just speed.
The plane.
It's not the speed of the plane. R1 and
The
R2.
speed was traveling
The speed it was traveling. Well, how is that different than the speed of the train?
because it's going with or against the jet stream.
It's going with the wind.
Speed.
Yeah, or against the wind, right? That's what we're noticing. So, technically speaking, R1, right? R1 is like this. I'm moving on a plane and the wind comes behind me. So it helps me, it assists me. So my speed that I feel is the speed of the plane plus the speed of the wind. Again, if you're running and you're jogging in the park and the wind's behind you, you feel that push you forward. So not only are you running at a certain speed, but it's your speed plus the wind speed that's helping you. But then when you're running against the wind, it's your speed.
Against the speed of the wind.
So it would be, instead of plus, it would be minus. So if we define two variables, okay, two variables we could call, let's see, we're looking for the speed of the jet and the speed of the wind. So let's call J the speed of the jet. Oh, not jest, but jet. Jest. And then for wind, let's call it W. All right, so those are the two things that we're looking for. So although we might be able to solve for R1 and R2 right now, We're not really looking for R1 and R2. We're not looking for the overall rate we feel. We're looking for the individual speed of the jet and the speed of the wind. So what could I replace R1 with now? What could I replace R1 with based on our conversation there? R1 is when we're with the wind, when the wind is helping us. Remember, that's what R1 was. So what could I replace R1 with? The jet speed? But we're with the wind, so I need the wind also. Yeah, J plus W, or J and W there. That's what the first equation becomes. Will, what does the second equation become?
J minus W.
Yeah, 1800 equals the jet speed minus the wind speed times 3, or times 4. This should be a 3 right here. So the idea behind this is that although if we solve for R1 and R2, we do get solutions, those are not what we were looking for. Remember, we weren't really looking for R1 and R2. We're looking for J, the jet speed. We're looking for W, the wind speed. So we have to specify what we're looking for in this problem. And now what we'll notice is that we have 2 equations and 2 unknowns. Can somebody suggest a way to solve this? There's a relatively easy way to solve this if you pick up on something. It's more work than it's worth if you do it another way. An easier way to solve. What do you got, Mike? And what to distribute, you can. Again, you get 3W plus 3J, or 4J minus 4W, and then you have to solve and go through it. There's an easier way to do it. An easier way. It's a little bit of a shortcut. You're going to eventually use the same technique. You're going to use elimination, yes, but you can't yet, because there's 3 and 4 out here. You can't ignore them.
Could you divide by 3 and divide by 4?
Yeah, divide by 3 and divide by 4. It makes it easier. You have J plus W and J minus W. And then elimination is very simple when you do that. So divide by the 3 and divide by the 4 in those equations. So the first equation, when you divide by 3, becomes 600 equals J plus W. The second one, you divide by 4, you get 450 equals J minus W. Sabine, explain to us why it's easier to do it this way than it would be to distribute the 3 and the 4. Why is it simpler to go this route? Yeah, you can go straight to elimination now. Just add straight down. You can literally add these 2 equations. It eliminates W. So if we distributed, that would work, but then we'd have to find a common multiple and make sure that they're opposites. It just is easier if you get the J minus W and the J plus W isolated. So we get 2J over here, and we get 1050 over here. The W's cancel out. The W's cancel out. As a result, the answer is 525. Now remember, that's the speed of the jet, which is a relatively normal speed for an airliner, around 500 miles per hour. What's the speed of the wind? If the jet speed? Yeah? 75. Quickly, how do you know? Where'd you look? Which one? Either one, yeah. The first one's probably easier because it's addition, but it doesn't matter. 525 plus what number gives you 600, right? 75 is missing there. So again, take this quantity and plug it in right here. 525 plus what value gives you 600? It's got to be 75. Now, before we write a verbal answer or make any statement, let's go back and look at that original equation that we had in the beginning. And let's try and understand the answers we would have gotten, because it's a little bit important here to see this. So jump back up. Okay, scroll back up in your notes to where we had R1 and R2. If I solve for R1 here and solve for R2 here, what do I get as my answers? What do I get for this one? R1 would have equaled what if I solve for it? 600. And R2 would have been 450. That would have been the rate on the way there is with the wind speed. Well, take a look. Look at the numbers we got earlier. Remember the 600 and the 450? It's the plane speed plus the wind is 600. Well, that's what this is right here. R1 was with the wind and it is 600. What's the average of these 2 numbers? What's the average of these 2 numbers right here? Frog in your throat, go ahead. 525. Kelly's right. The average is 525. And that's exactly what the jet speed was. And if you think about 525 from 600, that's the 75 that's missing. So had you gotten answers here earlier, this would have been the answer with the wind. This is the answer against the wind. So it's a little bit difficult to understand what our answers should have been if we didn't write this equation out. Now that we look back, it's obvious, the average was the jet speed. But clearly, the answers are not 600 and 450. Those are the speeds with the wind and against the wind. That's not what the question asked for. The question said, what is the jet speed, which is what we're looking for right here, and what is the wind speed right here. So our verbal statement would say that the jet speed is 525 miles per hour, and the wind speed is 75 miles per hour. All right? So again, the importance of this question, besides understanding systems of equations, and I emphasize this a lot, when solving a word problem, especially those who have been really struggling with word problems this year, when solving a word problem, make sure you understand what you're looking for. Identify what you're looking for as your let statement, which is the reason we went back up and said this up here. That's why we went back up and wrote this statement up here. That was really our let statement right there. Okay, so let's make sure that we understand what our goal is in the problem. Let's take a look at example 3. We'll save 4 and 5 for next class. So in example 3, Ben, can you read it for us nice and loud?
An exam worth 145 points contains 50 questions. Some of the questions are worth 2 points and some are worth 5 points. How many 2-point questions are on the test? How many 5-point questions are on the test?
So we have an unknown amount of problems of each type, but we know how many there are total. All right? If you got, say out of 50 questions, say that 20 of them were 2-pointers, right? If 20 of them were 2-pointers, how many points of the test would that make up? That portion right there. If 20 of them were with 2 points. 40 points. Why?
20 times 40 is 40. 20 times 2 is 40.
20 times 2 is 40. 20 problems were 2 points each. You multiply them to give you 40 points. So we understand that idea. Let's use that idea now in this equation, or this setup. So give me some let statements. It doesn't matter what you choose, obviously. Give me any let statements. Kelly.
Let T equal 2-point questions.
And I'm going to say number of 2-point questions, and then
Let F equal number of 5-point questions.
all right. I agree completely. That works to start. Give me one of the equations now. One of the equations, because there are definitely 2 equations. How do I know there's 2 equations? Because there's 2 variables. Give me one of the 2 equations so far. What do you got, Ryan?
F plus T is equal to 50.
Why?
Because it says it's made up of 50 questions.
Yeah, right there. That's the point right there. It says there's 50 questions on the test. So the number of total questions, F, is number of 5-point questions. T, the number of 2-point questions, has to equal 50. Absolutely. How about the second equation in this case? How about the second one, Ben?
2t plus 5f equals 145.
Yeah, very good. So the first equation related the number of questions, while the second equation had to do with the amount of points. And usually in these kinds of problems, where you're given rates of value for certain items, you're going to have a value, you're going to have an equation that has a number of items, or number of questions, and a second equation with a value of some sort, or the number of points total. Again, 2-point questions are worth 2 points times 2t. 5-point questions are worth 5 points, and that's why Ben told us 5f. And there are a total amount of points of 145 points. Now, before I solve this, because we could solve this next, it's also keen to look for your units. It might help you. The number 2 has units of 2 points per question. I'm just going to show you units. You don't have to write this. Maybe you can just look for now. The variable t is really t questions. That's what the units are there. Now, plus 5 points per question times f questions equals 145 points. So what you'll notice is this. The units of questions cancel here and here, leaving these units to be points. These units are points, and units of points plus points gives you units of points on the end. So what you can do is, and this is called dimensional analysis, you're just checking the units that they make sense. So if you need help when you're trying to figure these out in the test, think about what the unit should be, and that might help you verify that the answer you're getting is indeed correct. All right, but the whole goal again is to solve this system right here. How might you solve this system? How might you solve the system at the top? And again, there's always two methods. Which method do you want to choose for now?
I think
We got it.
substitution,
Why?
because it's right on the top, you just subtract that or subtract it.
Yeah, you could subtract one of these two on the top and use substitution. Okay, if you use elimination, what would you do? We'll use substitution. But if you use elimination, what would you do?
Multiply the top equation by -2.
Yeah, multiply this by -2, making this a -2f, -2t, -100. And then the -2, oops, I wrote them backwards in a sense, but the -2t and the positive 2t would end up canceling each other out here. Okay, but let's go with substitution. That's the first one we chose. So Charles, let's solve for f. Is that what you solve for?
I wanted to use different variables, but
Same difference in the end, right? So these are our equations now. If we solved for f in the first one. And then once we solve for f in the first equation, that's what we've got. Step me through this, Paul. What would I do next?
now you could
Think of the word substitute, right? Since you're using substitution.
and then yeah,
Where would that go?
with F,
How come? Because it's f, exactly. So whatever it's equal to, that's where you're going to plug it in. So let's drop it right in there. So we have 2t plus 5 times f, which is a big quantity, and that equals 145. So that quantity is 50 minus t. All right, so again, we take the value of f, the expression that represents f, which is 50 minus t, and plug it in for f in the second equation. So again, it's substitution method. So we complete this by distributing. Subtract the 250 from both sides, giving us negative 105. And on the left-hand side, 2t minus 5t is negative 3t. And at first it looks kind of weird because we're getting a negative answer, but it's actually fine. The negative answers are right because we're dividing by a negative in the end. What do we get? 35, does it look like? 35 times 3 should be 105. So how many are left of the other type of question? If there's 35 two-pointers? 15, because it's total of 50 questions, right? So there must be, f must equal 15. Because remember, together there were 50 problems. So if this makes up 35 problems that are worth 2 points, there's got to be 15 problems worth 5 points. Any questions on this? Understand the idea? So what I want to do is this. Tonight I want you to do about half the homework again like we did last time. So the homework from 3-6, we're not done with this section yet. I still want to do a little bit more, 2 more problems. The homework is listed at the bottom. So tonight you should be working on this. You should practice, I think they're all word problems in this section because obviously this is a problem-solving section. So try to get through about half of them tonight. Also, I mentioned this last week, you should really get started on those problem sets now, not later. Hey, please don't wait. When are they due? Yeah, because your next test is on Monday. Keep that in mind. Next test is on Monday, so the problem sets are due on Friday. You don't want to wait till Thursday night to do that. So you need to make sure you space out that time so you're ready for it. Tomorrow in class, we're going to do the last 2. And then I'm going to give you probably the rest of the period to finish up this homework. So I only have about half the period to work yet tomorrow, and I'll give you the rest of the time to finish your homework, which means even tomorrow night, you can get a little bit of a head start also again on the problems to do. Okay? So tonight, please work on about half of these. Example said, let's go into the problem. So, together John, Bobby, and Kristen have $70. So, right away, what do I know? What could I start with?
The total amount of money is $70.
Yeah, the total is 70. So, let's call them by their first initial, right? Just to make it easy. I generally do that. So, J plus B plus K equals 70. As Will said, the total is 70, so we put the total equaling 70. Together, John and Bobby have 39. So John plus Bobby equals 39. Notice what I'm doing. What did I do there?
You made two separate equations.
But what did I do in the second equation? What's obvious that you wouldn't normally write? Why would I do that? I did this on purpose. What was the
Well, you
reason?
left the space so you could see it if you tried to subtract, I guess. Or
Not for
Well, not-
subtract.
you can just see that the K is missing.
Okay, why would that be useful?
Substitution, maybe.
Maybe for substitution. Why else?
So you can find out what K is if that's the integer they're missing.
Okay, kind of like, so same idea that you can substitute and define K, but why else? What did we learn about? What have we used already that might help us solve these quicker?
Elimination.
Oh,
I mean, elimination, but
For the calculator, 0 K.
for the calculator, if you put this in a matrix, what goes here really? 0. So make sure you put a 0 there, not a 1. So I specifically left a blank there to emphasize that in your mind. Okay, so that's something that I do when I write out a system of equations. I'll align the variables and leave blanks where they're missing so I know it's a 0. All right? How about the third part? So we've already taken care of this and this. While Kristen has $4 more than Bobby. How do I write that? And this is going to be weird. So you don't have to write it this way if you don't want to. Okay, you can write it another way and then we can rearrange it to make it look like this. How would I write that Kristen has $4 more than Bobby?
K minus B equals 4.
Kristen's number or amount minus Bobby's amount equals 4. I would agree with you. And I would then rearrange it so it looks like the other equations, but I would definitely write it that way. How else could you write it? There's another way to write it also. That's one option. What's another option?
B plus 4 equals K.
B plus 4 is equal to K. And that says the following. It says that Kristen's amount of money is 4 more than Bobby's. Well, that's what this says also. If we simply add this B over, we get K equals 4 plus B. K equals 4 plus B. Okay, so that's the same thing. Now, the way we want to write it would be like this. B with a negative in front of it, K with a positive equals 4. And again, this is the same thing. Take a look, please. K is positive here, so K is positive. B was negative, so B is negative. 4 was on the right-hand side, 4 can remain on the right-hand side. And now I can get rid of these. I don't need them anymore. Okay? Again, this K minus B equals 4 is not needed. Now I've got my 3 equations. So I recommend that when you solve these equations, please, whenever it's a 3 by 4, unless I ask you specifically to do it by hand, use your calculator, use a matrix. It's much quicker. Solving by elimination is so timely with this. You could solve this by substitution as well, okay, and it's not as bad, but I personally would not. I would not recommend it.
I didn't do this, but I was looking, couldn't you subtract it and you get K equals 31, which is right?
Say again.
If you subtract the top equation from the bottom, you get K equals 31, and that's right.
The top equation from the bottom equation.
You just subtract, you get K equals 31.
So what's your operation? It's going to be negative B plus K minus 4, the third line, and then plus the negative of the first line?
Well, you know the two things that you wrote on the board right now?
Okay.
Well, the J,
I see 3 things though, Charles. Which one are you referring
the
to?
first two.
So these 2 right here.
If you subtract it, you get K equals 31.
Sure, absolutely. And then you can get B as a result from this one? Yeah, that's good. So Charles noticed that instead of using a matrix, he said take this one and subtract this one from it. J minus J is gone, B minus B is gone, K minus 0 is K. 70 minus 39 is going to give you 31. Okay, so yeah, K could equal 31. And if K is 31, what could you easily get?
B.
Yeah, you can get B because down here, right? So if that's 31, subtracting 31, you get 4 minus 31, negative 27. So B is positive 27. And then if you have those 2, you could take those 2, or you could actually just plug that into the second one to get J. J would then be 12. That works. Okay, but you have to see that you have to subtract these 2 right here to give you this K equals 31 first. Okay, so you can take the first 2, get K equals 31, take that K, plug it in to get B, You have V, take that V, plug it in here to get J. They're both here then. That works. Cool. Nice, Charles. I like that. Did anybody check? I'd like you to check on your calculator in practice though. So please try it. Let's make sure we're right. Okay, so pull out your calculator just to check so you can work on it. Because you have 3 variables in all equations, that makes it a little bit more difficult. Okay, but what we did there is a really good idea. You forgot it for some reason, so I'll leave harder for now. So now the first next to
Do 3 by 3, right?
3 by 4, because you have 4 columns. Take a look at the
Oh, right.
3 by 4, 3 by 4. Do you remember what you have to do when you're ready? What's the command? Don't you have it ready?
Yeah, you got that. I just don't know what numbers to put in.
So take a look at the coefficients, right? Remember we did this the other day. What are all the coefficients? 1, 1, 170. 1, 1, 0, 39. 0, negative 1, 1, 4. All the coefficients every time. I'll hook up my computer so you can see it. Oh, you should get the numbers that you got as answers. So you did, so check, take a look, maybe we can go back up. It doesn't look right.
Mr. Howard,
Yes.
what do you do after you like in the matrix? Solve, right?
Where do you go to after matrix? Quit. And then go back into matrix. And then call out the matrix A by just hitting enter. So once you have REF on your screen, okay, go back into matrix and just hit enter if it's on matrix A. You got it?
Yeah, I just did RREF. I just did.
You did ref?
Yeah. No, I just did the.
Oh, you just pulled out matrix A. That's why it showed what you saw on the board.
Yeah.
Can you help people around you to make sure everybody's on the same page? If you got it, help people around you so they know what they're doing. Sabine, you got it? Awesome. Right, you got it? You got it? Right. Does anybody need me to show it right now? Did everybody get it? Ben, did you guys get it?
I just don't know if I'm curious, I forgot it.
So go over to edit.
Yeah, I plugged in all the numbers.
Alright, then quit. Okay, go. Just press second mode. Just go out. Then go back into matrix. Go over to that. Go down to RREF. Watch this picture. Go back to matrix. And enter matrix. Those are 3 answers you got, right? Okay, so the first one is the answer for J, the second one is the answer for B, the third one is the answer for K. It's always like this, guys, remember. It's always down the diagonals, the letters they represent. So this is here for J. The second one would be B, and the third one would be K. Next, you're going to see the answers in a row. Questions at all on entering into the matrix on the calculator? You really should be checking these on the test. Okay, I allow you to use your calculator on these tests. You should be checking them. You should be checking them. All right? All right. Why don't you try this one on your own, or the person next to you, please? It's not that tough. It looks like a lot of words, but it's not that tough. You're given 3 scenarios, you come up with 3 equations, and you can go ahead and solve them. Work with someone next to you. Kelly, can you and Luca work together? And then you work over here. Ryan, just jump in. It's not numbers. The 3 of you guys can work together. And 2 over here, 2 over here. Why doesn't somebody read it out of this group, right? Charles, Will, Ryan. Charles, Will, Ryan. Why don't somebody read it so you can work on the problem together? Thirteen? All right, let's take a look at number 13. So this is from the homework now. Number 13 says, Marcia, I can't see it. Marcia flew her ultralight plane to a nearby town against a headwind of 15 kilometers an hour in 2 hours and 20 minutes. The return trip, under the same wind conditions, took 1 hour and 24, so she was with the wind that time, right? Find the plane's airspeed and the distance to the nearby town. So it's the same equations we used in class, just now we have to solve for different things. So let's use that generic equation. What's the equation I use for distance and velocity of some sort or speed? Say again? D equals rate times time. The distance traveled is, in this problem, do we know it? So it's unknown, right? So we're going to leave D alone for the first equation. And in the second equation, remember, it's the same distance in both directions. So I have, I have 2 equations there. I thought I was flipped back. Now, in the first situation, it looks like the headwind was with her or against her, and it was 15 kilometers an hour. So we're also trying to figure out the speed of the actual plane. The speed of the plane is unknown. Let's call that R. But when it's against the wind, it's losing speed, right? So I'm running into the wind, I'm losing speed. So this first situation, this first equation will be against the wind. And it says that the wind was 15 kilometers per hour. So we subtract 15 kilometers per hour from the plane speed. And it says that it takes 2 hours and 20 minutes. How do I write that? What's 2 hours and 20 minutes? 2 1/3. 2 1/3 hours. You can't write 2.20, right? That's 2 1/5. You need to know that 20 minutes is 1/3 of an hour. 2 hours and 20 minutes. On the way back, it takes 1 hour and 24 minutes. Anybody got this one? What's?
I just did 84, that was 130.
It's fine. Convert it to minutes? Yeah. Charles converted to minutes. I'm leaving it in hours because my units are kilometers per hour for velocity, for the rate that was given. So to be consistent with the units, it's the only way it would really mathematically come out to be true. What is it? 1.4. If you didn't know how to do that, let me explain. By the way, now you're with the wind, so it's a plus 15. So again, this is against the wind. This is with the wind. Notice the time it takes is much less when you're with the wind because the wind is helping you. Notice the rate is increased when you're with the wind because it's helping you. But when you're against the wind, the rate is decreased. Now you have 2 equations, 2 unknowns. You could solve a system. Okay, you could either, I would probably actually distribute the number on the outside this time. and then use a matrix to solve this. That's how I would solve it personally, just because it can be a little bit messy. I mean, another option obviously is to divide. How do you divide b by 2 1/3, right? It's going to get really messy along the way. You have this mixed fraction, you have to add them together. I would distribute the 2 1/3 to both, the 1.4 to both, and then just put it in a matrix. Make it easier. Okay, choose the way that's easiest. Now, to know where this came from, how did I know that 1 hour and 24 minutes was 1.4 hours? Well, this is the whole point, and then the decimal comes from the 24. Type in your calculator, 24 over 60. Type in 24 over 60. You're going to get 0.4. When you do that, you know that this is 0.4. Now, if you tried that with the last part, though, here, this was 2 hours and 20 minutes. If you type in 20 over 60, what do you get? 0.3333. You should know by now that 0.3 repeating is 1/3. 0.6 repeating is 2/3. You should know that. Okay, I'm going to assume you know that, actually. At this point, yeah, just solve. Others. Let's go back to the textbook on the other screen. Yeah, right, go. Number 3. Let's take a look. Find the measure. Let me zoom in a little. Find the measure of the angles of an isosceles triangle if the measure of the vertex is 40 less than the sum of the measures of the base angles. All right. So in this one, I'm sure if you could try number 3, go ahead. Draw an isosceles triangle to start. What are my labels going to be, Will? Oh, thank you. Sorry. And we're told that the measure of the vertex angle is 40 less than the sum of the base angles. B minus 40. Base minus 40. Okay, but it's the sum of them, so we should identify them first. Give me a step first. Go ahead. Say again? A plus A equals B plus 40 from the top one being B, you're saying? Well, if we just call these two A, right? The star, is that what you're starting with? We'll start with that. Then it says that the vertex angle is 40 less than the sum of the measures of the base angles. So just call this 2A minus 40. You don't really even need a system in this problem, right? Again, let me read it to you. It says, the vertex angle is 40 less than, so that's the minus 40, 40 less than the sum of the measures of the base angles. So make it easier on yourself. Use all one variable. Okay, I'm sure, I guess, in this problem, you could solve with multiple variables, but this is actually much easier to do it this way. You could call that B and then go ahead and add A and B, or 2A plus B together, and that works also. So we get 2A minus 40 plus A equals, Sabine? 180. Very good. We know that the sum of the interior angles of any triangle is 180. This is something that you might not know right away off the top of your head, but I'm just telling you now if you didn't know this yet, because I know you're taking geometry next year, but you've probably seen that before somewhere. What is the sum of the interior angles of a quadrilateral? 360. They increase by 180 for every n value higher. So a pentagon would be 540. Okay, a hexagon would be 720. They always go up by 180. So this is our equation, and now just solve, right? And then continue to solve for that. And you're trying to find the measures of all the angles. So once you get A, what should you remember to do? Make some sort of what kind of statement? Yeah, some sort of a verbal written statement at the end saying, the measures of the base angles are blank, and the measure of the vertex angle is blank. Other questions? Take a look. We still have a few more minutes. I can let you start working on this if you want to continue where you left off, or I could take more questions. Sabine? 14 on the next page? From section 2-3? Was this the review I gave you?
Yeah.
Cool. All right, hold on. Let me pull it up. From section 2-3. Right here, the length. All right, it says the length, oh, come on. The length of a rectangular sheet of paper was twice its width. After 1 centimeter was trimmed from each edge of the sheet, the perimeter was at most 1 meter. Find the largest possible dimensions. This is a good problem. I like this problem. We have to think about what's happening physically and use subtraction here. So, 14. But this is in section 2.3. So, what did you start by doing, Sabine? What's the easiest thing to start with? You wrote a little louder. Because the length is twice the width. Then what are we told? We're told that a centimeter is trimmed from each edge of the sheet. From each edge of the sheet. So that means that how many centimeters are we losing for the length? An inch here, or a centimeter here, and a centimeter here. So 2 centimeters from each, right? So the new rectangle is 2 centimeters shorter here and 2 centimeters shorter here. You follow what I'm saying? Because you're literally doing this. You're taking a centimeter off like this. Off each edge. Bless you. Bless you. If you lose a centimeter in all those directions, right? This is a centimeter here. This is a centimeter here. This is a centimeter right here. This is a centimeter right there. You lose a centimeter in all those dimensions. You're losing 2 centimeters in both. The issue is that the problem says now that the new perimeter is at most 1 meter. So we have to convert a meter into centimeters so that the units are consistent. That's the only key here. So what is a meter in terms of centimeters? 100, because centi means, what does it mean? Hundredth. Hundredth, right? 1 centimeter means 1/100th of a meter. So a meter is really 100 centimeters. And it says again that the perimeter is now at most 1 meter. So all we have to do now, say at most. At most means it's inequality. So 2w minus 2, there's 2 of those. And there's 2 sides that are length of w minus 2. And it's less than or equal to 100. So again, 2 lengths plus 2 widths is less than my max perimeter that I was given. That's the statement I'm really writing there. Remember, 2 lengths and 2 widths is usually equal to the perimeter, but it says at most 100. At most means it's less than or equal to 100. So I can then solve this. When I solve this, what am I getting? What am I getting? I have width as an option, length as an option, new width as an option, new length as an option. What am I actually getting when I solve for W? What is defined as W in these diagrams?
You're getting the W.
The original W, very good, Ryan. The original width of the piece of paper. And the problem says, find the largest possible dimension of the trimmed sheet. Trimmed sheet. That means that we need to plug the W to get back into the trimmed sheet formula. So let's say the W turns out to be, just let's say with this, okay, 12. That means that you plug a 12 in here, where it says W minus 2, and it means that the dimension is 10. Plug a 12 in here, that'll give you 24 minus 2, a dimension of 22. So 10 by 22, if W turned out to be, say, 12. Okay? So once you get the answer, you need to know what to do with that answer. W is the original width. The problem asks for the new dimensions. So plug W back into the new dimensions to get the new dimensions themselves. That'll give you the largest possible area. About 5 minutes left. I can take another question. You guys can work on a few more of these. I expect to see those who struggle with the quiz tomorrow after school. Shouldn't take too long, maybe 5-10 minutes with, what's it called? Only 3 questions on the quiz. Please make sure when you're doing your homework, you're showing your work, you're going through it, you're not just, putting down answers. I know, don't forget next week. problem set, there's no way you can do it here, because they're gonna, these are the third problem set, it's fine. It would take forever, so just create problem set 2, I'll use problem set 3 as the first period, the fourth quarter, and the second quarter. I used to usually push over the third one to the quarter, to the second, to the next quarter anyway. So that would be the 12th one at the end of the year. So to keep it 3 per quarter, this quarter was going to 2, and then from now on it'll be 3 per quarter. So the one for the previous quarter, and then the 2.
Right.
Just get this one, problem set 2 one.